Let's take a look at actually creating some classes. Classes can be used to model real-world objects, so let's go ahead and create a class called person. We do this by typing the class keyword and then the name that we would like to give our class, in this case is person, and then a colon. And below the class declaration, we can add attributes such as variables and methods. In this case, I will add two variables. So we will do fname for the first name, and I will initialize it to an empty string, and lname for the last name, and I will also initialize that to an empty string. Once we have created a class, in order to instantiate a class object, we would type a variable name. In this case, I'm just going to call it P. And then we would say equals, and then type the class name, followed by a set of parentheses. And this right here is the class instantiation call. This creates an instance of this person class and stores it in the variable. Once the class is created, you can use and modify the attributes within it using dot notation. So I am going to change fname to equal my first name Jesse and lname to equal my last name Warner, and I am going to print my first and last name to the console. So when I run this, we get the output Jesse Warner. However, creating a class like this is not recommended because these are class attributes. They are not instance attributes, meaning that code could be put anywhere in the program that can modify these attributes. So I'm going to remove this line of code right here, and above where I create my person object, I am going to say person dot fname equals and give it the value of Bob. Now when I run this, it's going to output Bob Warner. And any person object that I create from now on is going to have fname initialized to Bob instead of an empty string. So if you were planning on creating a class and then explicitly modifying every attribute in it afterwards, this may be an okay way to create classes, but that's not really how you want to go about doing it. There is a better way to do it. And to demonstrate this, I have created a new class called dog. And in it, you will see that I have this def keyword and then this method here that is underscore underscore init underscore underscore, and it has some parameters. This method here is the constructor, and it is a special method. Whenever a new instance of a dog object is created, it automatically calls this constructor with whatever values we pass into it. And you'll notice this first parameter here is self. This name here, self, is by convention is not required to be self. It can be any valid Python variable name. And the purpose of the first parameter here is whenever a new dog object is created, Python is going to pass an instance of that object into the constructor, and that is going to be put in this self variable. So this is not something that you need to worry about entering a value for. The only thing that you would have to enter values for is name and age. And you'll see down here we are using dot notation with this variable in order to access the instance attributes of the dog object. So here we have self.name equals name, then self.age equals age, and down here I have self.weight equals unknown, and I put this in here just to show that we do not need to pass a variable in to create an instance attribute. We can create an instance of the dog object and then sometime later explicitly set the weight to whatever we want to set it to. So now let's create two dog objects. We'll call the first one dog1, and we will put in the name dog, and then in parentheses this time we'll see that it wants a name and an age. So the first parameter will be Max, and then for the age I will make him 3 years old. And then for dog2 we will pass in the values of Bella and make her 2 years old. And then to demonstrate using the instance variables, I will print out some information about these dogs. So I have two print function calls here and an f string, and I am calling dog1.name, so it's going to be Max is, and then dog1.age, which is going to be 3 years old, and then it's doing the same for dog2. And when I run this, we'll get the output Max is 3 years old and Bella is 2 years old. Now, real-world objects don't only have attributes, they also have functions. They do stuff. So let's go ahead and give the dog class the method bark. And we do this just like we would create any other function. We use the def keyword and then the name and some parentheses and then a colon, and below the colon we would say what we want this method to do. And I'm just going to tell it to print the dog barks. I'm going to go ahead and remove these print function calls and instead call dog1.bark. And when I run this, we'll see that I get an error. It says dog1.bark takes 0 positional arguments, but 1 was given. But that doesn't seem right because I didn't pass a value into these parentheses here, so what's it talking about? Whenever you call an instance method such as bark here, the Python interpreter automatically passes the instance of that object in as the first argument. So we need to provide a variable that can hold that argument. So this is where we would again put the self variable. And then inside the method, we can then use this self variable to access the instance attributes for this object. So instead of just saying the dog barks, I am going to turn this into an F string and then in curly braces put self.name to access the specific instance object that is calling this method's name. So now if I run this, I'll get Max barks. And if I change the dog1 object to the dog2 object, we'll get the output Bella barks. Now let's look at an example of a class that uses both instance attributes and class attributes. So I'm going to go ahead and remove my dog class here, and I'm going to put in class counter. And you'll see we have the class attribute count, which I've initialized to 0. And then I have the constructor, and I am going to give each counter a name. And then inside the constructor call, it's going to call counter.count and add 1 to it. And since this is a class attribute, it is accessible by all instances of this counter class. So down below the class, I am going to create a counter object that I've called counter1, and I've instantiated the counter object and given it the name 1. And then I have a print function that is going to print counter, its name, and then the count for the class attribute count. And you'll notice that I am using the counter1, so this instance object's dot notation, to access this count variable. And if I run that, we get counter1 count 1. So now I'll create a second counter object. So I have counter2 equals counter, and I've passed in the name 2. And I have 2 print statements. Now I am going to reprint counter1.name count and access the class variable count by using the instance object dot notation for counter1 and for counter2 here. And when I run this, we'll see that the first counter1's count is 1. And then after the second counter object is instantiated, counter1's count is now 2. And then counter2's count is also 2. So as you can see, using an instance object to access class attributes is not a problem. But what happens if we try to change the class attribute by using an instance object? I'm going to go ahead and remove this print function call here. And then down below counter2, I'm going to say counter2.count and give it the value of 7. And then I'm going to create a third counter, which I will call counter3. And give it the name 3. And I will add another print function to print out the counter and its count when it accesses the class attribute count by using the instance object. And then I am also going to add a print function that prints out the counter variable from the class itself. Now when I run this, we'll see that we get counter1 count is 3, but counter2 count is 7 because we changed it here. But then counter3 count is 3, and when we access the class attribute directly by using the class name instead of one of the instance objects, it is also 3. What happened here was when we did this counter2.count equals 7, it created a shadow copy of the count attribute for the counter2 object. And because of precedence, the interpreter will first check the instance object's attributes to see if there is a count attribute in there. And since we created a shadow copy of it here, it will find it. And that's why we got the 7 down here. Now, if it wasn't in the instance object's attributes, it would then jump into the class attributes and see if there was a class attribute for the variable name that we were trying to access. And since we did this, we can no longer access the class attribute count using counter2. We would always get the shadow copy that the Python interpreter created back. So if you do have class attributes, it's best to try to leave those as class attributes and not do anything to modify them using an instance object. That'll be it for this video. In the next video, we will look at creating classes that have class and static methods.